We are the Omnibyte capstone team, and I'm Jay.
I'm Colin.
I'm Emma.
And I'm Dalton.
So, to start things out with, we are going to go over what Omnibyte is and what they do, and then what we were tasked with doing for them, what our schedule looked like for it, what we've gotten done along with a demo displaying it, and then what the next steps are with us moving out of it. So, Omnibyte develops mobile applications for people working in the field, so like plumbers and such, to help them sort of keep themselves organized. They also develop an app called Our Town, which is a way for small towns to help promote local businesses and increase their economy. And so, what we were tasked with, or what they needed, was increased functionality to help accomplish that goal. So, we were tasked with creating a geofence system to allow businesses to notify users of any deals or promotions as they walk by their business. And this would help some of the smaller businesses in these towns get people in the door and increase overall business within town. So now I'll hand it off to Colin.
All right, so I'm going to go over the schedule and progress so far. Oops, wrong button. There we go. Okay. So initially what we want to do, we were going to set up geofence functionality for our town, and then we were going to be creating a corresponding business webpage for businesses to enter deals they wanted to connect to the geofences. Here's the use case diagram that we initially started out with. So here's our initial layout of the 4 sprints we're going to do. The first one we wanted to do a design/setup phase, so we weren't going to really be working on anything yet. The second sprint we wanted to focus mainly on geofences, getting that up to date and running and everything. The third one we wanted to focus on the web application, so everything that was on the website. And then the last sprint we wanted to do like touch-ups, just cleaning everything up, making it look better. So we had a lot of unanticipated development delays. Environment issues kept appearing for us. We had many problems with the Ionic plugins not working since they're all GitHub based, so they're not professionally maintained. So we narrowed the scope before that we started Sprint 3, and we decided just to focus on the geofence functionality itself. So what we wanted to do for Sprint 3 after we revised it, we wanted to do customized notifications, speed checking to see if someone was driving so they wouldn't get a ton of notifications as they drove past places. We also wanted to make sure you can only get a notification once per day. We also wanted to make sure when you click the notification, you actually go to the business page on the Our Town app. And then we wanted to create a database table that housed all of our geofence information. And then we want to connect with the web service. And then Sprint 4, what we want to do is we want to be able to pull in the nearest geofences. And then we wanted functionality to modify the geofences. And then we also want to limit businesses to 1 geofence each so no one gets too greedy. And then we also wanted to create informational material so everyone would know what we did so far. So here we have our user story point laid out. Sprint 1, just on the other side, we did design, planning, setup, and research. And then Sprint 2, we did user location, basic notifications, and we added geofences. And Sprint 3 is when we went to almost a grinding halt because we had to reset everything we were doing and switch to doing native Android coding, which is why it was so low. So we basically had to relearn a lot of stuff. And then Sprint 4, which is what we just finished up, we did almost everything we wanted to do. So overall, we completed about 60% of what we originally set out to do. So progress so far. So what we have so far, we have background geolocation. We have a database table for geofences. We have a web service / web API that we can pull all the geofence information from. We have documentation set up. We have the validity checks for notifications to check to make sure they're all working correctly. We have customized notifications with certain icons for certain types of business type things like eating, electronics, books, stuff like that. And then we also have notifications appearing once per day. So the geofence strategy we employed, we basically had to make our own custom plugin for Android and for iOS. And so basically geofences are circles, and we only pull in active fences on the app, so only active ones can appear on your phone. And then we're doing date range checking, so making sure the deal is actually still on when you get the notification, so you don't get an expired deal or anything. And then background location checking, check where we are all the time. So now I'm going to hand it off to Dalton, who's going to do the demo.
Okay. So now I'll show you a quick video of the demo. Well, I won't. That's coming up next. So actually, we'll first go over what it looks like when you do get a notification. This is the format here, the logo up on the top left with the app name, which would be our town, as you can see on the left side. And then, we bring in the business name through the web service, and then a short description of the deal as well. And then the deal icons are predetermined by the deal category we have set up through the table for what type of business it is. And then as you can see, the next, these are all the notification icons we have differently. So say, if it was bar, we get the bar icon, or say it was for a furniture company like Slumberland, we get that one as well. So that was that. So now I'll show you the video. Oh, cool.
Whoa. Wow.
So as you can see, that's just a quick video and recap of what we have working. So that's pretty cool. And then some top highlights we've had for the project so far was we've had multiple code Saturdays, as we call it, where we got together at the library for multiple hours and did that and coded together. It usually turned out to be environment Saturdays with the various environment issues we've had and had to fix. Another top highlight was exposure to the various new technologies. We have had good team communication and dynamics. There's also been very many learning opportunities, which is always good. And then that also leads to good career experience for heading into the future. And then some of the lowlights, like I talked about previously, was the environments between the the 3 Windows computers and the MacBook that we have on the team. We also, our estimation skills are still need to be developed. They weren't as good as we hoped to be. There was issues with the initial framework, hence that's why we had to switch to the native plugins. And then, of course, balancing schedules and different holiday breaks. And then now I'll go over some issues and risks that we had towards the end of the project and then we've resolved. So the first risk, of course, was environments. And then we resolved that by helping each other out. It was good to have, not all the time everyone had the same errors, but if you don't bounce the issue off one to another, then hopefully we could figure it out. The next one was unable to get the geofencing to work initially with Ionic Framework. So then we resolved that by switching to native. And then our last one that we closed was unable to adhere to the timeline of the project. And then what we had to do was create good documentation for the handoff with Omnibyte. So now I will turn over to Emma with the next steps.
Okay, so I'm going to talk about the next steps of the project plan and its future. I don't know how to work the clicker. Okay, anyways, so the remaining tasks are right here. So as you guys saw, hopefully you remember, maybe you don't blame me if you don't, but we have to also create a plugin for iOS, and we have the basic functionality of that working. We just have to test it on the phone. We also want to check the speed checking functionality and get a better implementation about that. We also need to make sure that we're saving cross geofences on local storage, because right now if you close out the app, the notification delay won't work as well. We also these bottom ones right here, these final, I guess not all the bottom ones, but these two right here, the second to last ones, those are more functionality that would have been nice for leading into the web app development, which the businesses will need and they'll use to set up geofence notifications, and then final testing with all of this stuff. So for the project future, broke it down into 3 simple steps. So basically finish and polish up the geofence functionality, build the web app, and then integrate this into the OurTown app for businesses to use. So to do some of that too, we set up a few things. We've been talking a lot about documentation, which has been really important with our schedule issues. So one of the things we did is we created some informational materials for people who may not know much about geofence technology. So the one on the left is more geared towards businesses that would be interested in why should I be interested in this geofence technology notification system, and then the one on the right is more focused on just geofence technology as a whole and its benefits and possibilities that it offers. So then in the app, when this would be integrated in the app in way future, we were also in our initial design brainstorming with Omnibyte. We're talking about having potentially a deals page on the OurTown app. This is currently the OurTown app, if you didn't know. But basically it has all the other categories except for deals right now, but this would be a place where if they're in a community, they can click on this and also see all the available deals versus just walking around and trying to find them that way like a treasure hunt. So a little easier there. With the web app, this is a basic wireframe of that. So this would just be a simple web app that businesses could use to request a geofence notification that would be approved by a community admin for the community in which the business is. It would have a little bit of some stuff on the side too that would just give them more information. So about geofencing, like we said, kind of how the approval process works, so they know that and they know who to contact if something goes wrong or if they have more questions. And also just some information on how to actually submit these requests. And then what you see right here is what currently the admin portal for the community administrators look like. So what we would add on is the request little menu thing, secondary menu thing, where businesses could then click and be taken to this page that would have 2 different pages that they could toggle between. So the first would be the request inbox, which would pull all the requests from businesses that they submit through the web app into this portal, and they could approve or deny one at a time or multiple. And then the second would be kind of a backlog for the requests, just so for reference issues. So a little summary of our project post-mortem. There we go. Okay, so some stuff we got exposure to. We've been talking a lot too about all these technologies that we've gotten to use. A lot of us have never done mobile development before, much less mobile development for Android and iOS. We also had some fun times with version control software. That was good. And some languages that we've used in school a little bit, but we got to delve into them a little bit more, such as Java, TypeScript, and Swift. That one we haven't used that much, but we use that for iOS. We got some experience with agile development with our sprints and the planning that went into that, the industry, and different software that we used. Some skills that we developed that are essential for career success would be communication, teamwork, researching heavily, and problem solving, coding, and database manipulation. Regarding the geofencing, a lot of us, I mean, I personally didn't know what geofencing was until I took on this project too, so it was awesome to kind of look into that more and see what businesses are kind of taking hold of that possibilities that they have there and the different strategies you can implement it with. So that's all we have. Thank you guys. Do you have any questions for us?
I just have one. I noticed you had an icon for a food truck.
Yeah.
Those maybe move around. How easy is
They,
it?
yeah, they'd have to switch it. I was like, Taco Bros. Yeah.
The demo was great. I'm just wondering where you found the professional actors.
Yeah, we just pulled them off the street. So a bunch of randos.
Random people.
Oh, Jordan.
It was great to see that in action and see it working. So I appreciated the video.
Yeah.
And not just the demonstration. It was nice to see because you were out in space and you're walking, and
Yeah.
that's how it's supposed to work. So congratulations.
We're
on
just
that.
glad it wasn't raining either. We're like, we only have like an hour before it starts downpouring.
So, and then one more question.
Oh, of course. Yep.
So you learned a lot.
Mhm.
You talked about the technologies and so forth. A lot of struggles with the environment.
Yeah.
So what's the number one takeaway for your team on environments? Every one of the developers in our company has to deal with those types of things
Mhm.
all the time. So what would you think that is your number one takeaway on those struggles?
I think maybe like setting it up slowly is just because a lot of times we're like, hey, it's just let's just do this. You kind of like mindlessly like, oh, I'm downloading this, I'm connecting to this, but maybe like making sure. Because I know one time I forgot to push accept for permissions on something, and that caused a lot of issues. Just something little like that. And I think just communicating with other people too, and like there's a point at which like it's fine trying to figure out by yourself, but also to reach out for help. Because it did help, like we were saying when we were like texting our group chat and like on our like Code Saturdays too, and being like, hey, have you had this issue? If you have, like, look at this, or like, hey, I made me know a little bit about that, and that was really helpful.
To add on to that, one thing I was thinking would be that in the future it makes sense to have a document with errors that people got and how they managed to fix it in case other people run into the same issues. I know I figured out one problem, and then a few minutes later I found out Colin was having the same issue, and so then I was able to help him out. But if that document had been there, he could have checked there and found the solution a bit faster.
Sure, I agree.
As well as putting on that same kind of document all the proper steps for which each developer should take to, when they resync the project or when they rebuild it or that type of nature too. This would be nice as well.
Any other questions? Sure.
Okay, just regarding geofencing, is geofencing more of a GPS latitude longitude position-based system, or is it more, did you set up more for like proximity to a specific geographical location? Like, does it cover
So-
an area, or does it cover like one spot and then have kind of a pinging zone?
I would say it's more GPS wise. Yeah, because you set it per GPS coordinate to where you want, and then the radius around it, and then they mostly have, each native one has their own different implementations of their own that handle it for you, type thing. So I think it's more GPS, GPS, but I know they'll also work with the Wi-Fi and different network connectivity too. So.
You did a nice job of talking about what's left and things that need to be done, remaining tasks kind of thing. It sounded like some of those you're still trying to get done before the and I wasn't sure where that, what you're still trying to get done before you're all done.
We've been doing testing like most of this week. I was doing it late last night too. So we've been pushing really hard these last few days to try to make up for that last time of our late switch and everything, and that learning curve that we had to then overcome with that again. With that, I think we just have to add in a few lines of code to like make sure that it's refreshing the geofences. I think like after they move, so it's not just like just to like save on the battery power and stuff, like just make it more productive that way. We also have to merge some of our stuff too, because we were having some issues with our version control software. So we're just making sure that we all have the same stuff and we get that up there and find a documentation. So, yep. if that makes sense. Yep.
So, if we wanted to use this, or we were wandering around and wanted to also get alerted about spicy pie, when is this something that we'd be able to access, as consumers who are interested in using the product? Is that kind of planned when this gets phased in?
That would be up to Omnibite when they want to push that to production.
Our town's available to anybody for free today, and then the functionality will depend on the state of which we receive it and how much effort it is to roll out. We do anticipate a release this summer, and it may or may not make that release, but as soon as possible.
Yeah. Cool time.
Other questions? All right,
Awesome.
thank you.
Don't worry about your time. It's all fine. Ready?
I assume that's a yes. Hello, I hope everyone's having a good day so far. I'm Derek Evanson, and our capstone project has been focused around reviewing Microsoft's SQL Server integration services for John Deere. Our presentation has been broken down into 6 parts, starting with the introduction all the way up into our postmortem, where we'll then open for questioning afterwards. Starting with the introduction, our project team includes myself, Derek Evanson,
Jack Morgan. I'm Ryan Nelson.
and we've also been in constant communication with our sponsor, John Deere. A little bit about John Deere is that they manufacture heavy equipment for multiple industries. So agriculture, construction, forestry, lawn care. Here based in Fargo, they manufacture their integrated electronics. That would be their embedded controls, their displays, their user interfaces, and their specialty sensors. Which comes down to the problem is that John Deere collects a lot of data. This is from manufacturing and customer orders. And they move this data back and forth between different databases and different facilities. In order to do this, they use ETL software, extract, transform, and load, to then extract the data from some sort of source, transform and modify it in some sort of way, and then load it to another destination. Currently, their ETL software has gone through some changes, and they have asked our project team to review Microsoft's SQL Server integration tools as a potential replacement for the next 4 to 5 years. So at the end of the project, we're going to hand them our deliverables and our final report, and with some additional research that they're going to do, they're going to determine whether or not the cost, features, and ease of use and the performance is worth the change. Starting with our solution is that we're going to set up our own ETL lab. So we ordered several virtual machines to use on campus at NDSU, and we installed Windows Server 2016. We are then going to set up mock data that kind of represents what they're using and test out what SSIS has to offer, SQL Server Integration Services. Now the process, we took an agile approach. So that means we had sprint reports, we had backlog that we were maintaining, as well as burn down charts. We divided our semester-long project into 4 sprints, each being 3 weeks, and that included 2 project team meetings that we had, one in the beginning and one at the end. Additionally, we also had a sponsor meeting every Tuesday. For our first sprint, we gathered our requirements. We pretty much figured out what were John Deere's needs, and we kind of reinforced what they wanted. We then constructed user stories, and then we researched what sort of SSIS components we needed to prepare for our design. In Sprint 2, we implemented our ETL lab. We installed our data sources and the components that were required for it. We populated with sample data, and then we pretty much tested the functionality to make sure everything was connected. Sprint 3, we then updated our goals, we reviewed our current process, and then we tackled all of our high priority user stories, and we started the final report. Sprint 4, we finished the remaining user stories, which were mostly focused on miscellaneous SSIS features, and then we completed and polished the final report. Now, some explanation of what ETL is it is extract, transform, and load, which is you're extracting data from a source, you're transforming it, you're modifying it, either adding to it or combining it with something, and then you're loading it to another destination, or maybe even the same destination. So an example here that we have on the bottom is we have a couple columns from a SQL Server database on the, I guess, your guys' right, and then we are going to combine it with the columns with Oracle database on your guys' left. So ETL, kind of what it does is we create a package that has various tasks, and within those tasks we have stages in order to complete things. What we do is once we have this package, we then deploy it to a job, and then with that job we can then schedule it at a certain time. So we can have, let's say, 10,000 rows moved from Oracle to SQL at Monday 5 p.m., and we can also schedule another thing on Tuesday. We can also set up monitoring so we know what happens with the jobs, whether or not they've completed successfully or if they failed. We can set up notifications to email us like how long it's taking, whether or not certain stages within the actual job failed. We can also set up dependencies. So a job 1 has to be completed. If it does not complete successfully, we then also skip not only job 1, we can skip job 2, which was dependent. So what we have is for our ETL design is what we have all of our server 1 has all of our tools. And then our second virtual machine has all of our data sources. And then we allow access back and forth between them. Now ETL, and matter of fact, SQL Server Integration Services isn't just one sort of software. It has many components that you have to use interchangeably with each other. So on our server 1, we have Visual Studio, we have SQL Server Data Tools, we have SQL Server Management Studio, and SQL Server Agent. And then on the other virtual machine, we have our data sources, our Oracle database, our SQL Server database, our FTP server, and our file share. And our databases that we're using, we are filling with mock data, and we wanted to get a nice large variance of different data types with large amount of rows. So we used Microsoft's AdventureWorks for SQL, which has 1,000 records, and then we used Udacity, which had 4 million records. I'm going to hand off pretty much what we did in Sprint 3 and 4 off.
Thanks, Derek. So for Sprint 3, the two main things we focused on were tackling our Oracle client issue that we've been having and completing all of our main user stories for ETL jobs. So we'll quickly walk you through how this Oracle client issue came down. So the problem is that Visual Studio and SQL Server, they need an Oracle driver in order to access the Oracle database. And these are the particular drivers that we have access to. Now, in order to use those drivers, we have to download a particular software called Oracle Data Access Components. But this software actually has multiple bit versions of this that are available online, and they're each a little bit different. To complicate things, the particular runtime environments in which we're going to actually be running these packages are different. So for Visual Studio, if we're going to run packages there, we actually need the 32-bit version. But for SQL Server, we need the 64-bit version. So our first attempt at solving this issue was to install both of these different drivers onto our tools virtual machine. We actually ended up having a lot of problems with this. It took multiple weeks of trying to diagnose what was going wrong, and Oracle was just very difficult to understand. So we actually approached it from a different way. We had our original setup of 2 machines. We actually added a third virtual machine to this whole setup, and on here we replicated what we had put for our tools onto it. We also added the 32-bit Oracle driver, and just that one only. In this case, we actually got everything to work very well, and we were able to complete all of our user stories with this. In addition to focusing on that for Sprint 3, we also focused on completing our main high priority user stories, which focused on ETL jobs. The particular high priority ones were SQL Server database to SQL Server database, file share to SQL Server, FTP to SQL Server, and running an external script in SSIS. Some of the additional things we looked at in Sprint 3 were dealing with different execution styles, such as running the job ad hoc or in a batch, dealing with error handling in both the different job stages or for the whole job itself, and also dealing with logging and monitoring. In Sprint 4, we focused on the remaining user stories that we had committed ourselves to, as well as completing the final report. So the remaining user stories, some of the high priority ones, we're dealing with Oracle, so SQL to Oracle or the reverse of Oracle to SQL. We also dealt with creating an external script that actually could manipulate data inside what was going on. And we set up different notifications so that if there was a particular stage in the job that wasn't working right, you could be notified by email. Or if everything completed fine, you could receive an email for that as well. Some of the additional user stories that we focused on were dealing with data type conversions between Oracle and SQL, dealing with dependencies between different jobs so that jobs have to run in a certain order, and if one or two of the jobs is skipped, the third one will run. Dealing with reporting, where you can understand exactly what happened in a job, record all the error messages and be able to review that easily, and also deal with administration features of being able to set up different users who can all jump in and start executing jobs. Finally, we wrapped all this up in a final report. So this kind of breaks down a little bit of the outline of what's going on, but really it's two sections. The first section has to deal with discussing the project as a whole and really the process we went through and the different decisions we made to make everything happen. And the second part really focuses on explaining the particular features of SSIS that we looked into in hopes that it will help John Deere make their decisions. And with that, Jack's going to lead us through a quick demo.
Thanks, Ryan. So I'm going to walk through a quick demonstration of a simple ETL job using SQL Server Integration Services and SQL Server Management Studio. And I'm doing this so that we can kind of see the life cycle of an ETL job from building it and then deploying it and executing it. So here's our scenario. We're going to extract data from this AdventureWorks database over here on the left. We're going to do some data transformation in SSIS, and then we're going to load the data into two different tables in this other database based on the data transformations that we did. And I'll talk about those tables in a little bit here. So here's a look into the source data. These aren't all the columns from the source table, but these are the ones that I'm kind of concerned with. And in particular, I want to look at the freight column and the subtotal column. Freight is basically how much we spent shipping the order to the customer, and the subtotal is the amount the customer owes us before taxes and freight. And so what we're going to do is build a new column on the right there that kind of tells us what the relationship between freight and the subtotal of the order is. So first, we got to open up Visual Studio. This is kind of where we do all the design work for an SSIS job. So we'll go File, New, and then Project. And then we need to specify that we're doing an integration services project. And I named this one Final Presentation. So things to note here is we've got a new GUI because we're in an SSIS package. We've got kind of our design window right here with different tabs for control flow, data flow, parameters. And then on the left, we've also got our SSIS toolbox. And that's where all of the components that we're going to use to build this job live. So first, we need a data flow task. These are kind of the bones of an SSIS job. This is where we do all of the actual extracting, transforming, and loading of data. So we're definitely going to need one of those. So we'll double click on that, and it'll bring us into this tab in the design window. And then over on the left, you can see our SSIS toolbox also changed. Our tools now are more for like directly working with the data. So first, we need to specify the source table. So we'll use that source assistant right up here. If we double click that, it'll bring up this window where we need to specify the source type, which in this case is SQL Server. And then we also need to specify a connection manager. And connection managers are kind of how SSIS projects and packages talk to data sources and data destinations. So those are very important. So I'm going to show us how to set up one of those really quick. So if we double click that new, we get this new window, and we need to specify the server name and the name of the database that we're going to be pulling from. So I filled those in. We're going to click OK. And now we've got this source task in our design window. It's still got that red X there because we haven't specified the exact table in the database that we're going to be pulling from. So if we edit that guy, we've got a tab right here for Connection Manager. And if we simply, if we simply fill it in right here under this dropdown and click OK, we've specified our table. So next, we're going to use a derived column task, and that's how we're going to build that column that we saw on the far right. So we'll double click on that. And we need to supply the derived column with data. And the way that we do that in SSIS is right here with these arrows. The blue arrow is for the standard output of a task, and then the red arrow is for the error output. So we're just going to grab that blue arrow and point it at derived column, and now that task has some data. And if we edit this derived column, we get this window with the variables and parameters and columns over here on the left. And then we've got on the right here functions, typecasts, and operators that we can use to kind of specify what data is going to go into this new column that we're building. So I built one called freight percentage, and I've specified that we're going to add it to the data rather than replacing an old column. And then I've just made the expression basically freight divided by subtotal, and then I just had to cast it to a certain SSIS data type. So if we click OK, that guy's all set up. And now next we need to kind of tell the package which way to pipe output into the different destination tables based on that derived column that we just built. And for that, we're going to use a conditional split task. Once again, we need to pipe the output of the derived column into the conditional split so it has some data to work with. If we edit this guy, we get the same window as we did for the derived column. And I needed to build two outputs here, one called high freight orders and one called low freight orders. And the conditions for these, it's just based on that new column that we built. If the value is greater than or equal to 0.03, we're going to pipe it to one output. If it's less than, we'll pipe it to the other output. And I picked 0.03 because it was just kind of a nice median value that I found when I was looking through the data. So that's why I chose that. So if we click OK, then that one's all set up. And next we need to specify those two destination tables that we saw at the beginning. So we're just going to use a destination assistant up here, and it brings up the same window that we got for source. We need to specify a new connection manager because it's in a different, or these two tables are in a different database than the source table. I'm not going to show you how we set those up because it's just the same as the source. So we've got two destinations here. We need to pipe the output of the conditional split into the two of those. So we'll grab an arrow from that blue arrow from the conditional split, point it at this task, and with a conditional split, it'll ask you which output you want to move into this next task. So for this one, we'll do high freight orders, and then I did the low freight orders into the other destination. We still got those red X's down there, and the reason for that is we haven't mapped the input to this task to the actual column in the destination table yet, so we still need to do that. So we'll edit one of them. We'll just do high freight orders. And when we hit edit, we've got this window with the mappings tab. And it gives us this nice GUI for mapping from the input columns to the task to the actual destination columns in the destination table. So we'll click OK. And I did the same for low freight, but we won't look at that. So our package is now ready to go. We're going to deploy it now. And the way that we do that is we go over here and we'll right click and hit deploy package. So I'll hit next, and then in this wizard, we need to specify where our integration services catalog lives. So first we need to specify the server name, and once we've got that connected, we can just hit this browse button here, and it'll bring up our integration services catalog, but we have to specify a specific file inside of there to hold this job. So we'll hit new project, and we need to call it, I just called it demo. I'll click OK, OK, and then it gives us this review screen. I'll hit deploy. Looks like everything deployed correctly, so we're going to get out of Visual Studio and we'll move into SQL Server Management Studio now, which is where we'll be able to access that integration services catalog and schedule job and also execute it. So under SQL Server Agent right here, we can see that there's a files or a jobs file. We'll right click on that and hit new job. It'll bring up this window for us. So the job, we'll give it a name right here, final presentation, we don't need a description. And then we'll go to this steps tab right here. You can have steps in these jobs that aren't integration services projects, but for this one, we're just going to include that. So we need to create a new step for our project. So if we click new, we just have to give the step a name. We need to specify that it's an integration services package, and then we actually need to point it to the particular package that we want it to execute. So it'll bring us our integration services catalog once again. We specify the correct package, click OK. And now we can see that we've got a step in our job. Next, we're going to create a new schedule for our job. So we'll click new down there, and this brings up this window. For this particular job, I just wanted to show off that you have a lot of flexibility with when you can schedule these. I did this one in particular on Mondays at 8 p.m. And then the nice thing is that it gives you a nice little readout of what your schedule actually looks like down here in case you made a mistake. But we'll click OK. So we see we have a new schedule, and that's all that we're going to do for this particular job. You could also do alerts and notifications and targets over here, but we're not going to worry about that for the time being. So if we click OK, we can see that the final presentation job got added to the job folder under SQL Server Agent. But we actually do want to execute it ad hoc right now. So first I'm going to show us the destination tables. So I'm connecting to a different database here, and I'm just doing a simple select all into both of those tables. And we can see that they're both empty. Then we'll jump back into our integration services catalog, and we see our project right here, package right here. If we right click and hit execute, we'll get this overview window, and we can see that everything succeeded. And if we go back to our destination tables and we run that same select all, we can see that we wrote a little over 31,000 rows to each of those tables based on the freight percentage column that we built. So now I'm going to pass off to Ryan for the postmortem on our project.
Great, thanks, Jack. So let's do a quick postmortem on how this project went. The 4 things we'd like to look at are the successes, the setbacks we had, lessons learned, and recommendations for future work. So let's start with the successes. We started off this project not knowing anything about SSIS. It's not like we were doing a Java project or a JavaScript project, so we had a lot to learn. And from just the few short months we worked on the project, we were able to quickly get in there and master the particular aspects of SSIS that John Deere wanted us to look at. We also did pretty well with teamwork. The idea of we never worked together on a team, and just having to manage different schedules and all of these array of tasks we had to do, I thought we did a great job dividing it up and conquering it all pretty well. Finally, the third thing that we were really proud of is we created quite robust documentation and just went over and above what was actually required. As far as particular setbacks go, the first one we could talk about is choosing the particular platform for hosting our ETL lab. We'd originally anticipated using Microsoft Azure and started working using that software, but quickly realized that it would have been much better to host it at NDSU, so that actually required us to rebuild the whole system there. Another setback was dealing with version compatibility of software. When we set up the system at NDSU, we originally used Visual Studio 2017, but it actually turns out that the particular version of the Oracle software we needed to use wasn't compatible with this version that we were using for Visual Studio, so we had to go back and rebuild the system again. The third setback we had was dealing just with system configuration issues. We're not system administrators, and we don't focus on database administration here in this program. So we were struggling with having to set up the firewall correctly and deal with user accounts so that everyone can have access to everything and everything works correctly. And then we also had a setback with the Oracle client issue, but we talked about that already. So as you can see, this definitely impacted the velocity of our project. This is just a quick burn down chart of what we had originally anticipated the project would take as far as effort and when we'd get everything done. And you can see that over time, we just added more and more effort to the project to tackle some of these setbacks we had without John Deere adding any particular new user stories. So that leads us to lessons learned. Some of the things that could have really helped us is if we had installed the system more incrementally. And the idea is, as we're working with virtual machines, if we had been taking snapshots as we go and succeeded with one particular thing, that would have helped us. If we're struggling with something new, we can always roll back instead of having to rebuild the whole system again. It's also been really important to keep the sponsor in the loop. For the first half of the project, we've been meeting with John Deere pretty much on a weekly basis. And then in the second half, we were able to ease up a little bit and do maybe every other week, every 3 weeks. And this was really great for us. When we started the project, it gave us a way to very quickly dive in to understand what the project was about and what we needed to do. And later on, as we dealt with different issues, it gave us a sounding board and just helped keep everyone on the same page. Finally, the third lesson learned would be to seek out experts. So when we were first setting up these systems, especially with Oracle, if we were able to find someone who's been setting up Oracle systems frequently and regularly, we probably could have avoided a lot of the problems we had early on and could have just saved us time in the long run. That leads us to the recommendations for the future. So SSIS can do a lot of things. As you saw in the demo, there's so much more it can do. Even that, though, it's a bare bones tool because it's free. So one of the things that other groups could look into is using third-party extensions. There's a lot of neat things that other people have created that complement SSIS, and it's worth exploring those. Another thing would be dealing with performance testing. We mostly focus on understanding the features and what was out there for what SSIS could do, but we didn't focus on how performant the system's actually going to be. So that's going to be very impactful for John Deere, and it's something to look into. The third thing would be dealing with scalability. SSIS works really well if you have maybe 10 to 15 jobs, but as soon as you have to deal with 50 or 100 different jobs in a production environment, the way the system actually organizes everything and keeps track of the different versions may not be adequate for John Deere's needs, so it's something to look into. And the fourth recommendation would be to consider the maintainability of multiple software components. SSIS isn't just a standalone software package that gets updated just by itself. It has 4 or 5 different components. And if they're all updating on a different schedule, that's a lot to keep track of. So it's really important to have a good plan moving forward of how you're going to approach that and keep everything on the same page. And with that, thank you. Do you have any questions?
I guess, was there any remaining work, or did it kind of turn out that everything that was agreed upon at the beginning was finished and there's not a lot beyond that?
You want to tackle that one?
I mean, there were stretch goals that we pretty much from the beginning decided weren't going to get done. The big thing was working with Docker. So we'd be basically resetting our entire ETL lab using Docker rather than, well, we were going to do Azure, but hosting it on NDSU. But we pretty early on discussed that was just not going to happen probably. So we weren't committed to those. But everything that we were committed to, we finished.
A couple of little ones. You mentioned the documentation and things, which I think is exactly what John Deere wanted. But how big is that?
The document right now I think is 87 pages, so it's quite robust.
It's a lot.
We're not every single user story that we did, because some of the user stories were dealing with final project and that, but a lot of the other things, I would say, 75% of the user stories are definitely thoroughly documented in that report.
Yep.
And then for each demonstration that we planned on having with John Deere on Tuesdays, we also had an alternative backup. So we also have pre-recorded videos and screen captures of what we would have demoed. That's
Sure.
also something we'd potentially include.
Right. Very true.
And the other's just kind of a little one. But when you schedule all these jobs, you had the one where you had a failure in the middle. Is rollback just included in what you do, or do you have to worry about that if you have a failure partway through?
Sure. It's something that I don't think is in part of SSIS itself. That would be more to deal with the particular database management system that you're using, and whether it's transactional based or how you actually approach it there. So if the job fails to run, it's going to complete all the steps up until that failure, and it doesn't roll anything back. So you might have a cleanup step in your job that looks through and says maybe if something fails, it skips to a later step which rolls things back. So you could definitely manually include some of that, but it's not set up inside SSIS itself.
I would definitely set up a situation that if task B was dependent on task A, it would then, if task A failed, it would switch over to task F, which would handle all the cleanup duty and just revert everything.
Yeah. Right.
And then just to be safe, I'd also probably add in a notification step.
Sure.
Yeah, sure.
Yeah.
Any other questions? Thank you.
Thank you.
Good. All right, thank you everybody for coming out today. Appreciate it. We are the Next Resources Capstone Group. My name is Riley Bannock. I primarily worked on the back end of things, as well as some of the front end pages for interacting with the server on our website.
I'm Alexis Sari. I work mostly with the connectivity between the front end and the back end, as well as some stuff with the server.
I'm Austin Tower. I mostly worked on the front end, especially the shift assignment page.
So this is our contact information if you want to get in contact with any of us. We have both of our sponsors up there, as well as the 3 of us. So what our company is Next Resources. They're a fracking company in western North Dakota. What they're looking for is a product that allows dispatchers to send messages to crew members. What we're going to do is provide them with a prototype of that, and then from there they can give their product, either expand it to multiple locations within their own company, or to sell it to other locations or to other companies.
Now let's talk about the terms that we will use throughout this presentation. A job is a job at a location, and a shift is a period of work at a job, like morning shift, day shift, night shift. And a crew member is an employee of Next Resources that is being assigned to a shift, and the dispatcher will assign the crew members. Now let's talk about the problems and opportunities of this project. The current issue at Next Resources is that the dispatcher has to assign to all of the crew members and notify them all through text message individually. The problem with that is, of course, it's going to take a lot of time. Now, our solution will meet their short-term needs by giving a website that allows the dispatchers to assign the crew members to their shifts. In addition, it allows text messages to be instantly sent to all of the other crew members with a click of a button. And, last but not least, our system gives the crew members a way to respond by just clicking yes or no on the message. And for the long-term goals, Next Resources plans on selling this to other companies. Now, our solution provides a UI-based way to assign crew to their shifts. It allows them to be notified automatically, and it makes it easy for them to confirm. And, of course, this is all stored on a database, so no paper.
All right, so just to take a quick and brief trip down memory lane for our development process, we had 4 different sprints, like most of the groups in our class. For the first sprint, it was primarily focused on just getting used to all the different tools that we had worked with. We had never worked with the Nexmo API, for example, which is the service that we use for text messaging. We also were not familiar with Bootstrap really at all, which is kind of what we use to actually design our pages. So during the first sprint, we got familiar with those tools, and we actually were able to set up our server. That includes, the Internet Information Services, which is kind of the basic thing for Microsoft servers, as well as setting the template and the foundation for actually making our SQL database and populating it with tables and different entries. So for Sprint 2, we set up our domain and had a point to our IP, as well as integrated things such as Bootstrap and Link. If you've ever used Link before, it's a super nice way of getting around PHP. Basically just treats the different tables as objects in your program. We also, since we had the foundation set, we created our SQL tables. Throughout the development process, we probably changed those tables about 4 or 5 times, but at the very least, we set the foundation for those. As well as set up remote access to our server via a connection string. This was super nice because as we're testing things, we didn't actually need to upload everything to our server. We could just run it locally, and then it would just grab everything it needed from our website. And then for Sprint 3, we started to solidify what we wanted everything to really look like. So this includes Austin's shift assignment page, for example. Had probably a couple hour meetings with our sponsors going through what exactly we wanted it to look like. As well as we started to get all these different tools that we're working with in Sprint 1 and 2, and then just started implementing them into our front end. For Sprint 4, we pretty much just finalized the way we wanted the UI to look like. This includes getting all of the pages that you use to interact with the database up and running. So, adding jobs or reviewing jobs. Same thing with shifts and users. And that's kind of the general overview of what we did during that time. A couple tools that we used that were really useful. Obviously, we needed a server. We used a Windows 2012 R2 server. They have something called Internet Information Services, or IIS, which is just how you host your actual website, as well as we hosted our SQL database on there. And then we used Bootstrap, which the primary thing we used for that was just using the grid layout that they provide for you. It allows you to kind of divide the page into 12 different sections and then put things exactly where you want them to be. We also use Nexmo, which is what we use to actually send the text messages. The way that works is you load a URL and then it sends it to Nexmo, and then they process your account key and the actual message you want to send, and then they just send it right on out. Link, like we've talked about before, is probably one of our more useful tools. It allowed us to avoid a lot of the PHP. You basically take the tables from your actual server, and then you just put it into your project, and you're able to declare everything as if it was an object. So, the job table I can just declare as job, new job, rather than actually going through all the different PHP.
So then some major functions. Our project is designed for the dispatcher for the website. So a dispatcher can create new jobs or shifts, as well as new users. A user is a dispatcher or a crew member. Dispatchers can also assign crew members to shifts, send out those mass text messages that get sent to every single crew member who's on a shift. And then dispatchers can also view which crew members have confirmed yes or confirmed no about whether or not they'll be attending a shift. From the crew member side, it starts with a text message from the dispatcher. The crew member can see a text message, click on a link that's inside there, be sent to a web page and either hit a button of yes or no for whether or not they're going to be there for the shift.
All right, so now we're going to head into the demo here quick. I'm just going to set that up. Awesome. So this is kind of the basic template. This is just the home page. There's really not a ton going on here other than just some basic information and then different navigation points. So we're going to jump right into the jobs portion of the page. So on this page, we have every single job that we have in our database. And the way that this works is we have a bunch of code in C# that basically just runs through our database and references a couple different classes that we have to actually build these different containers. And then it just puts it on the page based off what it has. We also have a basic filter on the left here. So for today, if we wanted to do first, it'll just show everything that's happening after the first. And then as kind of if you wanted to add a new job, for example, we have a different add job page. So for this, I'll just do, hopefully not misspell anything. So then upon submitting the job, it just redirects you right back to the job review page, and you can see that it's been added to the actual page. So we also kind of have a similar layout for shifts. The way that we did this is we have every single job, and then within each job is every single shift that coordinates with that. On this page, you can also send out the actual SMS to the different crew members that are working on each shift. So I don't know if you guys want to turn the volume on your phone just for fun. So if I select this morning shift here, and then I want to send out the notifications, it's going to think for a hot second. So when you receive a text message, it'll have a lot of the different basic information that you need to actually get to your shift. So this includes the actual time that it's starting, the latitude start and the longitude start, as well as some of the job information. Alexis, do you just want to talk about the actual link that you get with that too?
Yeah, so inside your text message, you have some contents for the primary details of your shift. So if you like, you can click on the link that's inside of there. It sends you to one of our web pages. It has the job that you're going to be working on, your shift. It has the times that you'll be working, the locations. And then from there, you can hit either yes or no, whether or not you're going to be attending the shift. Everything is live, so I'll refresh the page, Riley.
So as you can see, both Austin and Alexis decided they wanted to confirm their shifts. They did this by just following that link and then clicking that button and then updated the database. And of course, once we refresh the page, it'll show that in green that they have confirmed. If either of them really wanted to, they could have said, no, I'm not going to be there. And then again, that'll just say they have confirmed that no, they're not going to be at that shift. And we just chose red text for that. Once you confirm to something, however, that blue text just basically indicates that you haven't even looked at it. So once you click something, it will change it to a color, and you can't change it back to has not even looked at or has not confirmed. We do have an add shift page. We're not going to go through and fill all this out, as much fun as form filling is. But that's just kind of a general idea of how you would actually fill out a shift. This looks for every single job that we have in our database. And then you can select one of those, as well as your time range and everything else that you need to actually declare a shift. So now I'm going to pass it over to Austin here, who's going to explain the shift assignment page.
All right, the shift assignment page is the page that the dispatchers will use to assign the crew to their jobs. We have moved to March 9th, which is a day that we know that there are shifts. So now let's just select the first job, and now it will display all of the selected shifts for the selected job. Now, of course, for each shift, if you hover over the top title of them, it'll give you all the details. And in addition, underneath is all of the crew that have been assigned to that job. Now let's just select that shift. So now you can remove one. Let's just remove me. All right. Now I'm not on there. Now let's just say, let's add Tori to it. Right now he is on there. And now, just because if you have more than 4 shifts, you can't see them all, let's just go to the next one. Now, unfortunately we don't have any, so let's just go back. Now, and so one more thing is that now you can't see all of them, but that's because they're all at different heights. So let's just scroll down a little. So from this you can tell is that the top one starts at 2 a.m. and ends at 11 a.m. So that concludes the shift assignment page, and now let's go back.
And then just to kind of show you here, so on this shift page, Tori is now assigned and Austin has been removed from it. So if we wanted to, we could resend out those text messages and then go from there. And that's everything you have, correct?
Yes.
Cool. Perfect. All right, so to kind of get into a little bit of behind the scenes and how the actual website works, we have the SQL database. This is kind of the general setup. As we've mentioned before, each one of these tables can be represented as an object within our program. So both the job, shift, and the user, for example. So the shift assignment table, we pretty much just use that to actually get multiple crew members assigned to one different shift. And then this is kind of an example of one of the classes that we use to actually build the different like dynamic web pages for the job review page and the shift review page. Rather than like declaring all these HTML elements over and over and over again, we just created a couple of different methods within this class, which we then only had to call maybe 1 or 2 lines, and then maybe run a for loop for every single job or shift we had in the actual database.
Now, on the shift assignment page, one of the big issues I had was what is known as post back. In other words, when you hit a button, the page would refresh. However, after that, it would update, so the updates would not be shown. So to fix that, I added onto each button something that would cause the page to reload.
And this is some example of the code for actually interacting with the database and our tables. So again, we're using link. That allows us to access the tables like objects and allows us to create new rows inside of there. So if you look at the top one, that job, temp job, new equals new job, that is accessing the job table. And then the contents that's below it, and then this insert on submit and submit changes does, as you saw, automatically submit it to our server. And then the stuff that Riley was showing you grabs it from the server, refreshes on the refresh of the page. If you look lower, then this submit job button, which is where we added the job earlier in our presentation, is all that a programmer needs to type for adding a new job is this job next resources implementation, which is part of the class above. .create job, give it the parameters from the text boxes, and then hit enter, and everything works. And then some issues and risks. The largest risk that we had throughout the project was just our understanding of how all of our different pieces worked and how they would interact with each other. So one of them was, the Nexmo API. We just kind of chose Nexmo because it said that they could send multiple text messages at once, and we hoped that it worked. And then another one was, setting up ASP.NET with our server, getting our connection string working. Again, they were risks because we didn't know if it would work, and they didn't become issues because we managed to figure it out. There's also, Austin did a great job of dynamically populating his shift assignment page, as well as, sometimes there's post-back issues that he managed to fix. And then one of the biggest questions that we had during the midterm was how are we going to scale our project? So we went to our sponsors about that and we asked, how many people are we going to have to deal with in this database? And they essentially told us, assume that there's going to be no more than about 100 crew members at a time. The way that Next Resources can expand their project to more locations is by giving a new dispatcher at a different location a clean slate as far as the database goes. So dispatcher in Minot is going to have a completely different database than the one that's in Fargo. And then again, that's how it would expand for other companies.
So to kind of review everything that happened during our project, we certainly learned quite a bit. And one of the themes that really discussed was pretty much communication and being able to just plan for everything that happens. So, for example, we had a bunch of regular meetings. We probably met every Tuesday with our sponsor, and then every Thursday we did a lot of documentation. And then we spent at least 1 or 2 days, primarily on the weekend, actually doing the development of our project. Having this consistency made sure that we're all on the same page. I mean, again, we saw each other every 2 to 3 days, whether we liked it or not. And we were able to keep in touch and understand what we were struggling with and what we weren't struggling with. One of the things we learned towards the end that we kind of wish we would have done more consistently was actually just setting up maybe 1 or 2 or 3 small goals that just absolutely needed to happen or like needed to get done. Otherwise, we'd be behind. When we had a time crunch, it proved really useful just to know that we had 4 to 5 hours if we really needed it, or if it took 2 hours, it took 2 hours. But we were just always making consistent progress, at least towards the end with that strategy. A lot of things we learned too when working as a team was kind of this divide and conquer. I mean, each of us had different aspects of the project that we were working on. And rather, if we wanted to change something on, I don't know, for example, I wanted to change something on Alexis's part of the project that she'd been working on, rather than trying to relearn it or trying to get through and, relearn it and then just rewrite it, I just ended up just talking to her and she could normally figure it out in 10 to 15 minutes. Obviously, we learned how to set up a website, which we'd never really known how to do before, as well as like a database that we could connect to that, as well as just using a few different APIs and tools that we weren't familiar with. And again, communication is just super huge as a team. So for future groups, we recommend always have those regular physical meetings. A couple times a week was really nice for us, especially being able to see our sponsor in person once a week was super helpful. And then also start early and start often. I mean, we had a weird issue with Visual Studio where they have a folder that automatically gets created every single time, but if you try and load that folder up to GitHub, it would cause a big conflict issue. And that took us, an hour or 2 to figure out, and it would have been nice, or it's nice that we dealt with that early rather than 2 or 3 months into the project.
So let's talk about how the project can move forward into the future. Now, one of the things that can be expanded on is that the crew members can respond using just text messages instead of having to follow a link. This would allow non-smartphones to be used to respond. In addition, we hope to improve ease of use. And one thing that we wish we could have done, but we hope that will be done, is that that the equipment and trailers can be added on to be assigned. And one improvement for the future is that we hope that the shift assignment page will be cleaned up. Now, let's conclude after the 20-odd minutes that we've been speaking. Now, the problem at Next Resources is that the dispatcher has to text every crew member, which takes an enormous amount of time. Our solution will allow dispatchers to go to a website and assign crew members. In addition, we will give them a button where they can just click it and it'll send messages to all of the crew members. And last but not least, we'll give the crew members an easy way to confirm and an easy way for the dispatchers to see that they have confirmed.
Are there any questions?
A little tiny one and then a thought question. A little tiny one is, if you went through where you added a person after you'd sent out the mass
Yes.
thing. If you resend, who gets it?
Right now it would resend to everybody, but we can just make a new method that only grabs the people who haven't been sent messages yet. Right now it would send to everybody.
And then the other question is just what the ability to have equipment was mentioned at the very beginning but wasn't included, which was fine because I really like what you did. Have you done anything? Can you name something you've done in your design to make it easier to deal with equipment or less hard? Or
Yeah, so we have a start location and an ending location. So if there's a delivery of a truck and a trailer being delivered from site A to site B, that starting and ending location would be a good spot to start with, as far as the constraints go.
Yeah, we're hoping that would still allow for deliveries at the very least, so somebody knew where they could start and end with that.
So you used a Nexmo API to distribute multiple texts.
Yep.
Are there fees associated with the use of that, or whoever is distributing those texts, or a limit on per day or per month? Or?
So I don't remember the exact cost. Was it like
Half a cent?
I think it's even less than that.
It's 0.005 of a cent to send a text message. Our sponsors were nice enough to make us an account, hook up all of our email addresses, and then they gave us $12.
Okay.
Yeah.
Got 2 of them.
And then as far as like how many you can send, Nextmo says about 30 text messages a second. So for example, when we initially did it, we did not take that into account. So we blasted, all 5 or 6 text messages, and only like the first one would go through because the server couldn't pick it all up. So we just kind of had to tell our server to wait for a little bit after every single text message. That's kind of why you'll notice why it maybe takes at least a couple seconds for it to process and send out all those messages.
Thank you.
Thank you. Good job, team.
So we are the Upper Great Plains Transportation Institute team, UGPTI from here on out, if you please. I'm going to go through the introduction. So I'm Jackson.
Spencer. Brandon.
Nathan.
And we were selected to work for UGPTI. And what they are is an education research outreach center based at NDSU. And what they focus on is the costs involved in transportation infrastructure and looking into some research on that. They're guided by a lot of local agencies around the area. Alan Dibbing, our project advisor, who we thought would be here but couldn't make it. He's been a really good resource for the project. He's been working at UGPTI for about 10 years now, so he's very knowledgeable on the subject, and we've been able to ask him a lot of questions, and he gives good feedback right away, so it's helped guide the project immensely. So the problem we have here is they gave us this old application, and what it did is it has a whole bunch of inputs here, as you can see, and you'd go through, you'd fill all of this out, and at the end you would calculate it. And it would show you how much it would cost for you to take over your own shipping. There were a lot of problems with this, though. For example, it's become so outdated that a lot of users, when they tried to run it, it simply wouldn't even work, which is obviously a pretty big problem. The UI is also exceptionally outdated. It has that early 2000s look where they have all of these tabs up across the top. Things have shifted more nowadays so that you rework this UI flow that they used to have and make it a little bit more linear. So it's a step-by-step process instead of just throwing the user in and having them try to figure out where to go by themselves. A couple of other problems this application has is you can see this GVW is outlined in red here. The problem with that is this looks exactly the same as a user input, like payload right up above there, but it's not. It's an output, and that ends up being pretty confusing for users. It's not very clear communication, so we wanted to fix that. And we also wanted to move the logo up to the top left. So.
All right, I'm going to be talking about the scheduling we went through and the progress that we've made throughout the year. So, talking about the schedule at the start, we pretty much just follow a standard 4-sprint over the course of 3 to 4 months schedule, with the first sprint being pretty much project initiation, documentation planning, the second sprint being making a lot of diagrams and documentation and starting a little bit on the coding, and 3 and 4 being the main source of all of our coding and implementation. And then now we're at the presentation at the end, so as you can see there. So when we first decided to break up the tasks we had to do, we decided to do it in this user story model. And as you can see, we have all of the things that we did in our project. We did like computing the data, entering all your information, viewing your summaries, doing the calculations, features like importing inputs and saving inputs and printing, and a lot of other things like that. And you can see that we've got these story points value associated with them, pretty much the amount of work that would go into them. And after we went through it all, we documented our actual story points, pretty much meaning how much work they actually took compared to what we thought. And as you can see, computing the data ended up taking about 8 more story points than we anticipated, which is about 80% or so So that's a pretty sizable increase. What else? The entering data about the cost is just a little bit more difficult. Importing saved inputs was a lot more difficult. We had it rated at around a 2, which is very low, and it ended up being about half of computing the data. So as you can see as well, sensitivity options were much more difficult in the same vein, and we kind of overestimated the work on some of the advanced settings as well. So as you can see, we kind of underestimated a lot of our work, but ended up getting most of it done. So talking about our some of the stuff we completed is we decided to kind of reinvent the project with this linear flow model instead of a free-flowing model. And what that kind of means is that you have multiple pages that you go from start to end, not in between, not like just choosing an arbitrary one to go to. So you have the trip, and then the costs, and then your truck, and these are all of your inputs for what you need to what you're looking to input, and then after that comes the cost summary output page. So kind of the reason that we decided to do this is because we think it's a lot more intuitive for a user, and it also gives you kind of a sense of place in the project. You can't get lost at all. We decided to come up with some diagrams that kind of just detail how the user uses it. As you can see, the end user looking at, it's kind of just following that kind of pathway that I described. It's not really important to go over. Some other diagrams we came up with for kind of assessing the calculations. So total, what we've pretty much got done is we've got these all of our calculations implemented. There's over 100 calculations in the whole project. Stuff like calculating everything per trip, per ton, per hour, per mile, the totals for fixed costs and variable costs, and we'll show you what that all means in the context of the project. We went through a lot of formatting, stuff like changing your precision, your decimal places, being able to increase and decrease that. Stuff like comma separators, just for more readability. And we implemented this thing called sensitivity comparison. And what that is pretty much is you're able to do your calculations, and then you're going to have a nice page where you can propose changes to your inputs and see how that affects your total costs. So it can be very useful in quickly checking to see if maybe my fuel price goes up or something. How does that affect my all of my costs as a percentage? And so we're going to jump into a short demo real quick. Pull this up. That's not the right folder. No, that's not it. Where is it? This one. All right, so if you'd like to discuss it, or who's going to start?
You start with
my bad. Okay, my bad. Sorry. All right, so as you can see, we've got we've got this very.
Spencer.
What's up? Oh, you can't see it. Oh, okay. We've got to do this. There you go. So we've got this first page, which is the trip characteristics form, and what this is pretty much it allows you to change all this information, like your origin, your destination, your tons of commodity, loaded versus backhauling, wait time, your speed, your distance, and your GVW and your TARE. And if you don't know what some of these things are, there's some nice tool tips, like GVW stands for gross vehicle weight, and the TARE is your empty vehicle. So you change all these inputs. For example, let's make this a 400 distance trip, even though Fargo to Bismarck is only about 200. And this is kind of the indicator of this free-flowing model this linear flow model that I described, where you go from characteristics to the costs, and you can see it's kind of indicated by the blue color there. And then we've got all these cost inputs, which are things like how much you're paying your drivers, your sales tax, your interest rates. You can kind of go through that pretty quickly. On the truck characteristics page, you have all of your stuff for your trucks and your tractors and your trailers. You can change the configuration and the type of truck that you're going to be using, which does affect some of the things. And you've got this annual utilization here. It's an important value. And that's kind of why it's at the top and bolded. It's because it's very important for people who know what they're doing. So as we move forward, we can talk about the output screen a little bit. And as you can see, we've got this form with pretty much the bulk of what you're going to be doing here. And so I'm going to calculate this, then hand it over to who am I handing over to? Okay, yeah. Go ahead, Nathan. Sorry. It takes a moment because my computer's bad.
As you can see, kind of flashes like this as it's running through every calculation, but after it's done, it will display everything all at once. So we have at the very top here, it shows the origin and destination of the trip that we're planning, and then it shows under variable costs, just like the per hour or per trip kind of stuff, which then also, so you can see like per mile, how much does like this specifically cost us, how much does this cost us per trip, and of course you see it totals everything. During fixed costs, sometimes it's like that as an input variable you say, this is how much this is going to cost us in 1 year. So then we take that and we kind of like reverse engineer it and say, well, per mile that means about this, because this is how many miles we're eventually going to be taking across the whole thing. And then we can figure out exactly how significant that is over the course of the whole year. There's opportunity cost, we have overhead, sales tax. So all of this is kind of calculated, and we can see how much like fuel consumption costs will cost us throughout the whole year at the very end. And then at the very bottom we have the grand total, and we can see like this will cost us like about $5,500 per year just for everything, for fuel, for labor, for everything. And then I think we can look at the sensitivity page next. I'll hand it over if you want to go for it.
All right, so here we've got the sensitivity page, and what this allows us to do is modify certain variables by percentage. So maybe you get done calculating all this stuff out and you show it to your boss and you say, look, it's going to cost us about $700 per trip. And he says, well, that's great and all, but it's coming towards the end of the year here, and our fuel prices are expected to increase by about 15%. Numlock tricked me. You can put in that 15%, calculate it, and this is how much that would change with a 15% change in fuel price. The same also applies, of course, for negative values. And for a while we didn't have this new grand total trip cost, but as we were testing it, we realized that's where most people are going to be looking when they're interpreting these values. So it's an important thing to display for them, and you don't want to force someone to say, oh, it changes by 5%. Well, let me just go look at the per trip and calculate that myself, when we can just take care of it. And we can also highlight here why annual utilization was considered an extremely valuable input. So if we actually increase our annual input here, that's actually going to decrease our total costs even further. Because there's such a big investment involved with purchasing all of the vehicles and equipment in the first place, you can actually make things cheaper for yourself by using them more. So like if you spent $1 million on a truck but only went, for the ease of the example, you went a mile. That's a really bad investment. You just spent $1 million to travel a mile. This helps you see exactly how much that change is going to take place with annual utilization. And Spencer would kill me if I didn't show you this. So you can pull up multiple sensitivity tabs as well and compare side by side the changes that would be involved. So with all that being said, I'm going to hand things off to Brandon, and he's going to talk a little bit about user value importing and exporting.
All right. So first off, minimize this. We have a imported value all the way back here, or exported value, but I could just export again. And you see it pops up right on the desktop there. I will just go back to the beginning, and then I'll import it. So that one will give us the exact same values. This one was modified, right?
Yeah, that was modified.
Okay.
I think.
Yep. So what this one did was just change Fargo to Fargo 2. So that's just a simple simple modification. and you can actually double click on this. It just pops up as a
Try again.
as a simple text file, and that is the basic one.
Yeah.
And then we'll go over to the one that we just imported. And right here, we got the Fargo 2. Another cool thing that we implemented that was wanted by Alan was a way to export all the variables into a CSV so that they could import it into Excel. And this was pretty cool because Excel just picked it up right away, and it shows all of the variables already in different columns, along with the name of the variable and the amount. Let's see. Just to show that, we'll hit delete, export that. Gives you a little window saying that it was successfully saved to the desktop. And it should look the same. Alright. And with that, I think that's about all there is for import and export.
I guess you could really quick show off the putting some nonsense values in there.
Okay, yeah.
So the all the inputs are type safe. You shouldn't be able to crash the program by putting in Q1000 for the annual miles or something. It realizes that doesn't make any sense, and it sets it to the default. Did you add something that didn't make sense?
Nope.
Okay.
I can do that.
I thought you did, and I'm like, oh, it didn't work.
During testing, putting some negative values in produced interesting and amusing results in the calculations as well.
Yeah, like you shouldn't be able to divide by 0. That doesn't make any sense. So
I can tell you, you make a killing if you pay -$2 per gallon of gas. So.
Then your annual utilization is very important.
Yeah.
We'll import. I guess we'll have to import the old file to get the default value since I just changed them in there.
Oh.
Did I just drag something out?
You're okay. Should be the top one there.
Yep. There we go. File successfully imported. So now we should have the risky values in there. Yep, there we go. Annual utilization is what I changed, and tires per tractor. Then I'll calculate this, and we should get a. Okay, I know what I did.
Yeah.
I didn't calculate it after that.
See what you're saying? There you go.
And there are our different values. And that should be it for import and export.
So I guess we can, just to show, gives you a notification that all the values, all the fields that were wrong, it tells you that it's not a valid input and that it resets it to its default value of 8. And then it does that. So I guess we can continue on with the PowerPoint. Is that working? So would you like to take over for the issues and the issues we overcame?
So here are some of the issues and risks we encountered. First off, the division of the responsibilities at the beginning was unclear. After we got that sorted out, everything seemed to flow fairly well. Scheduling conflicts between different members. Some of us had classes and we couldn't meet at specific times, and it was kind of a problem. Web of input and output calculations was way more complex than we expected. After we got that done, it was pretty easy flowing. Occasionally overwriting work by mistake, that caused some issues and extended our time by quite a bit. We had some formatting issues and fixing fatal errors that caused crashes. Overall, we overcame most of these, so everything works well.
Reflection.
And I'll take over for reflections and next steps. So here for kind of a reflection and postmortem. Overall, like, we successfully took this old program and brought it into the modern age with C#. We made a new GUI design that is linear and is much more intuitive for someone trying to figure out, okay, what does this all mean? Like, where would I put these inputs and what is the outputs that I'm actually looking for? We did all of our code base is pretty well documented. Like all the methods that aren't just the obvious like get set methods are have a quick comment of like, this is what this actually does, just for people in the future who happen to work on it. More post-mortem stuff, the actual running of our project. Found out it's very important to clearly divide responsibilities and expectations for each member throughout the whole year, instead of just kind of letting it, okay, we have to get this done, and just kind of letting it go free from there, because sometimes it wasn't clear what exactly we're supposed to be doing, or if we should have waited on something else. And also be very direct when dealing with your sponsor, and just clearly communicate things like right away, and say like, we need this information like by this point, so we can really start working on things. And next steps for anyone in the future who goes back to work on this and expand it. Number one, add more sensitivity variables. Some things that maybe someone who's more familiar with what exactly people who use this program would actually want would like. We have field costs, but sometimes like be aware of other changes that might come up. Expand the functionality of the CSV exportation, just to have more outputs, just like stuff like things like fixed costs, instead of just listing every single input that you have, just to better able to keep track of that information. Obviously, improve modularity, so there's less hard coding of things. Have things like stack in arrays, so in the future you can just add to that array a lot, and it'll still work fine. You don't have to rewrite the whole program just to compensate for that one little change. And have more test cases for that. More data visualization, like we visually show how significant each expense and variable is to the overall calculations and overall totals. More exporting in more formats in a stable way. We export into, as you can see, CSV, and we can try to export and PDFs, and try to export into things that you can copy and paste and get a really solid shot of all the information that you got from running this program once, just to save for later, and make sure that it runs on different operating systems and streamline resolutions, so it doesn't go, for example, down past the bottom of the page and make it impossible to continue to the next screen. And I think after that, it's just any questions?
Was there any attempt to add new features, or was it just make sure it's exactly what it was?
There were a couple new features, like for example, just as an example of one new feature, all of the exporting and outporting were new. Those weren't things, but I mean, these decimal digits, although they're not they're not super important, they are a new feature technically, being able to increase the precision. I don't know, anything else?
The user inputs, exporting them and importing them is actually a new feature as opposed to the old model. Additionally, there's it updated. Now we have 4 decimal places. Additionally, this truck type and truck configuration, for the spreadsheet model, like the values were there, the user could import them, but they weren't actually interacted with. He just had some defaults put in. So this is this has actually been implemented now, that changing these will change the calculations slightly. There was something else as well. Oh yeah, the sensitivity. We didn't know this for sure, but Alan actually said with the old model, the sensitivity tab basically didn't work.
So the whole tab was pretty much a new feature.
So a working sensitivity tab is the new feature. Yeah.
Type safing, that's a new feature. That's a big new feature.
Oh, yeah.
You can't crash it by typing the wrong things.
Yeah.
Go ahead.
Those are good. I guess I was thinking more like, since that was done, there's the big wide tires on.
Oh, so yeah, so I guess I could talk to that a little bit. When the original application was made in Visual Basic in like 2001 or something like that, there was, you know, we didn't just update from that. We made our project based on a updated Excel spreadsheet implementation that the UGBTI people put together in like 2011 or 2012 or something. Yeah. So that it is more up to date than the old version. So go with that. Yeah.
I guess, could some tweaks to the user interface be made? At first, when you kind of got to this page and it has a whole bunch of NA,
yeah,
I was immediately kind of wondering, why don't I have results? And I didn't think to even look for a calculate button, or wouldn't think, why do I need to click this? Couldn't it just
have it
when
calculate?
I do that?
Yeah.
That goes ahead, or maybe even something if the calculations take that long, throw a little progress bar up just because the flickering seems weird.
Yeah. I guess. Go ahead.
Just
Sorry.
The other one quickly, just because we're kind of running out of time. We don't need to answer any of this.
Okay.
I would never think to click the sensitivity button again to get another pop-up window because nothing works like that. So maybe you need a button in that window that says create another one of these.
Darn.
So it's a great idea. I just would never
think to do it.
That.
Yeah. All right. That's good feedback.
Thank you.
Other questions? All right. Well, thank you.
Thank you.
Hi, we are the Orbital ATK team. I'm Justin.
I'm Justin as well.
I'm Tyler. And I'm Nathan.
We are working with Orbital ATK and working closely with our sponsors, Will, Eddie, and Mary. I'm just going to go over quickly what we will be covering in this presentation. We'll start off by doing a brief overview of the company we are working with, and then we will discuss the problem that we are tasked with solving, tell you a little bit about the development environment, our project schedule, and then we'll take a dive into the data analytics that we were able to capture. And at the end, we'll do some demos about encryption and different network configurations that we were testing, and then kind of sum all that up and tell you what we learned in our experience throughout the project. So Orbital ATK is a leader in aerospace and defense. They deal with things such as flight systems, defense systems, and space systems. And more specific to our task was embedded software. And the branch we're working with right now, they only use single isolated nodes, so they wanted us to look into a mesh network that had multiple nodes communicating with each other running an OS.
Alright, so just some brief terminology that most people will probably know. When we say node, we're talking about just a piece of physical hardware that likely has sensors that can communicate with other nodes. A mesh network is a communication network made up of a bunch of radio nodes that all work together to transport data to and from a client and then to and throughout the network. Internet of Things, or IoT, as most of you probably already know, is just a network, is the idea of a network of physical devices that each have some sort of embedded electronic that allows them to communicate and connect with each other. All right, so our initial problem was we needed a way to detect movement or just some sort of, any sort of changes in some sort of field or military base or maybe battle situation. And obviously this needed to use secure network traffic, and we needed a way to monitor this network that we have so we can monitor the data that is coming through and to the network. So our initial statement, which serves as our solution to the problem, was we needed to create a self-organizing, unified mesh network. And we were initially tasked with targeting the CC2650 STK board, but that actually changed throughout the semester, and so now we are targeting the Z1 board. And some of the data that we could transmit through the network was accelerometer, magnetometer, and light intensity data. And obviously we needed to use encrypted traffic so bad guys couldn't hijack our data. And we needed a way to monitor the network so we could gather analytics about the network, as well as the data from the sensors. We also had one sort of stretch goal, and that was to support a single node command message, and we would have liked this to have a max latency of around 1 second from transmission to the node processing of the message.
Okay, so I'm going to talk about the environment that we're working with, and there's 3 main components to it right now. And the first one is Kuja, and Kuja is a network simulator that we use to get analytics from the networks that we would set up. And Kuja itself comes on the Kentucky repository, which you can pull from GitHub. And then on top of that, we were using Ubuntu to contain all of that stuff. And so for our development stack, we mostly had Windows and Mac computers that would load up a virtual machine with Ubuntu on it, and then we would pull the Kentucky repository. And in the beginning we were using Riot, but as you see it's crossed out. We ended up changing that partway through this semester, and now we're only using Kuja with Kentucky.
So next we'll talk about kind of our schedule as the semester progressed. In our first 2 sprints, we were focused mostly on setting up our environment. Riot and Kentucky didn't really want to mesh well together, so it took us a long time to figure out the problems and kind of what operating system we could load them both onto so that we could compile and run them both within one environment instead of having to transfer back and forth between systems or anything like that. In our third sprint, we got everything working together, and we were focused more on actually building our the operating system, the messaging system for our nodes. What we came upon was kind of a series of problems that we couldn't really work around. Riot and Kentucky, well, Kuja, the emulation environment, didn't like to work well together. So eventually we ended up scrapping that and just focusing on Kentucky for our operating system. So finally, in our 4th sprint, we did a lot of work, and we got Collect View working, which is a way to view metrics about your network. We got encryption working. We added a second border router to the network, so that way we could support more nodes and have less of a power draw on specific nodes. Just made it more efficient. So progress and what we've done over the semester. Kind of a rehashing of last slide. So we did a ton of research, in especially the first 2 sprints. We set up our environment. We completed a lot of tutorials, learned a lot of things about IoT devices, the different operating systems for IoT devices. We switched our focus from Riot to Kentucky. We found the correct board that worked well between the 2. And finally, we found the correct board that worked just well with Kentucky. We collected network analytics, and we were able to emulate the network within Kuja. So encryption. Encryption is important for Kentucky and UDP, or networks in general, is because most networks have a way of verifying like who is saying what. Usually there's a password to join the network, something like that. But UDP doesn't have that, partially because it's for very small devices that don't have a lot of RAM or computing power. So that's why we needed it. Otherwise, people could just join the network, basically copy the messages that were sent out, spoof them, and just kind of overload our network with a whole bunch of false information. Encryption was completed in our last sprint, and hardware acceleration is built into a lot of the boards that's supported by Kentucky, but it's not supported by Kuja. So the real world numbers that we get and the numbers that we get from Kuja could differ a fair bit. And Kentucky supports up to 128-bit encryption. So here's an example of our network simulated within Kuja and it working with its encryption. In this one, you have number 1. The first node is actually the border node, so that's where all the information gets sent. The node number 6 is the unencrypted node, the node that's trying to kind of work with in the network. It's a false node. And 5, 3, and 4 are nodes that are encrypted. So in this browser, you can see the information from our border router, and you can see the border router only detects the encrypted node that's next to it, which is neighbor 5, route 5. It doesn't actually pick up the 6th one because it can't talk to it since that one is unencrypted. In the next slide, I kind of changed up the network a bit to work around it. And then finally, we got it working, and you can see it connects with all the encrypted nodes, yet moves around the unencrypted node.
Okay, so I'm going to talk about network configurations that we worked with, and we tested 4 different configurations recently and tried to get some information and see which ones are more ideal for which types of scenarios. And so on the left here, we have a 36-node network with all these yellow nodes you see are all client nodes, and those are sending data to this green node, which is a border router, which is where we actually can visualize the data. And the difference on the right side is that we have the same network, except we have 2 border routers, which should speed things up. And then these two. We set up a pseudo-random network. If we set it up randomly, there might be like gaps, and they might not even be included in the network if they're too far away and outside of the radius. So we made it more random than the square grid. And on the left side, we used 1 border router, and on the right side, we used 2.
Right, so like Tyler mentioned, we used 36 was the number we were able to get to, and this was because the Z1 board has a max number of routes and max number of neighbors. So we were able to play around with those numbers a little bit to create the biggest grid we could, and we had it set to 32 routes and 4 neighbors. And the reason we could only go that high was because the Z1 board is limited in memory, so when we change those numbers, we use up more memory. We have to make sure that we fall in the category of the memory constraints. This is some of the data we were able to collect through CollectView, and when using 2 border routers, the biggest thing that stands out is the average number of hops is much lower, and this is because there's a shorter path to the nearest border router. A number of hops is basically just referring to how many jumps it has to go through to each node to get to the final path destination. And then also the average routing metric was also lower with 2 border routers, and that's basically measuring the cost of the messages. So when it has to go farther, it has a higher cost per message. So obviously when you have 2 border routers, it doesn't have to go as far. So the cost is less, making the network faster and more efficient. And then it also has a direct effect on power consumption, which Justin will touch on.
So looking a little bit more into the average CPU power, for the square network layout with the 1 border router, we had 0.057 milliwatts of power. When we added the 2nd border router, that actually decreased slightly. This is likely due to the fact that on average, the distance, which is equivalent to the number of hops that each message has to take from the node to the border router, is less than with the 1 border router. So we see that decrease in power usage. When we compare that to the random layouts, we actually see the random layouts are a bit higher than the square layouts. This is likely due to the fact that they're less efficient, and there are some nodes that are much closer together and far away, and so they will likely have to transmit through more nodes to get to the border router.
And to summarize what both Justins just said, was essentially what we found was that the square grids seem to be more ideal in the fact that if a node drops out, like let's say number 12 just dies, 7 can just go around that and like get straight to 1 a slightly longer way. But if you're in a random network and a node dies, you might completely isolate the nodes around it. So the square grid's better in that regard. But also, the square grid was more consistent in the number of hops we see, whereas if you have a random network layout, then you really have no idea how well the nodes are going to be scattered. And we also found that in both configurations, having an extra border router decreased the amount of hops it usually takes to send a message. So more border routers is usually better.
So next we're going to talk about network repair. Network repair needs to be triggered when a node either drops out or is added to the network. It makes sure the border router knows how it can get and talk to that router and that node, and how that node can get back to the border router. So by default, network repair is triggered once every 10 minutes over Contiki, and it's very important because it can leave the entire network vulnerable. If network repair isn't triggered after a border or after a node dies out next to the border router, then it could potentially lose a lot of information that's being sent to it. So you kind of want a happy medium of when to repair the network and when not to. Part of that is just because the majority of the power consumption of each node comes from transmission. And so every time you try to reconfigure the network, trigger the repair, it takes a lot of power to do so. So here's just an example of network repair real quick. In the first slide is the network, everything's fine, happy. It can get to node 5 can talk to the border router. The border router is the node number 1 in this example. In the second example, or in figure B, the node number 3 drops out of the network. So now they can't talk to each other, and then figure C is just how the network would reconfigure itself. So it could talk to node number 5.
Okay, so I'm going to go over how we actually ran those tests and found that data that we showed you earlier. So this is the environment that we're working in, and this is just kind of the blank canvas where we can add different types of nodes and see how they interact with each other. And so we've got some nodes set up here. The yellow ones are, again, client nodes, and the green one is the border router. And so the first thing that we did was we wanted to make sure that everything was within the radius of each other. That way they can talk, because kind of need that. And then so the first thing that happens when you start the simulation is that the network starts to configure itself and figure out the paths to get to all the client nodes. And so to actually start collecting data, we have to click on our border router and then go to the collect view button over there. And that gives us this nice window where it houses all the information that we can collect from the network. And it doesn't initially have any information in it because it takes 60-second intervals to actually have the client send information to it. So it's not like you're going to get everything all at once. It's going to slowly keep accumulating information. And so after we've got some information, this was consistently what we were seeing with average power consumption. All the nodes in the network were using about 60, or kind of around 56, that area. And most of that is being used by the radio listen. As you can see here, almost all of it is being used by the listening on the radio network. And another interesting bit of information we can get is the network graph. And basically, every black dot you see there is corresponded to a node. And this diagram is what the simulation has gathered and how it actually sends the data to the different nodes. And this is the initial data. This is the data from when the network initially starts. These aren't the fastest paths that you could actually take to a node. Like you can see here that it would actually, if you wanted to send data from the border router to node 12, it would actually go through a fairly bad path instead of just going directly to it because they're within the radius. And as the network goes on, then this gets fixed out and it'll find the fastest paths that way. And probably the most important information we got was in this node info tab. And this showed us a wide variety of data for every single node in our network. And it also gave us nice averages so we could see the average number of hops and the routing metric. And the ETX is, it's a term used in mesh networks, and it corresponds to kind of what Justin was talking about earlier, the cost of sending a message to that node. And you want lower numbers in that regard. Yep. Okay.
All right, so when working throughout this whole process of creating a mesh network, we ran into our fair share of problems. Initially, the majority came when working with Riot and just trying to cross-compile, and we ran into tool chain issues and compiler bugs. But once we were able to change our focus to Kentucky, it really sped up our progress, so we didn't have to worry about cross-compiling anymore. And then when working with finding the right board, we settled on the Z1 because it had compatibility with Kuja and Kentucky. And it, like I mentioned before, it is limited in memory. It has 92 kilobytes of flash memory and 8 kilobytes of RAM. So we didn't have a lot to work with, and to get around that issue, we had to delete unused modules. When I say modules, basically just different functionalities of the board, like UDP messaging, having the client view work within the nodes, things like that. So we had to decide what we needed and what wasn't necessary at the time. And then at first, when using collect view, our data wasn't displaying, and we found this to be we had to make sure the port numbers were consistent between the border and client nodes. And even so, we still only got it working on 2 machines. That kind of ties into some of our risk. Was collect view can be somewhat unreliable, where some days it would work, and then the next day it would just stop working. So we would spend our nights trying to figure out why that was the case, when really we would have been like to make more progress on our actual problem. And then one risk that we will always have to deal with in this project is the Z1 board not having a lot of memory, because as we add more functionality to our network, we have to make sure that we don't go over the threshold of how much it can take. So we kind of have to choose wisely what we are going to add to our files. When looking over our whole progress and our work that we did on this project, we really found the most important part was communication. And through the second half, we started to ask more questions more frequently with our sponsors, and that really helped us. And we were able to see actual progress. When instead of banging our heads against the wall for 6 hours, we were just asked the question and we were able to move on, and that was really good for us. And then definitely switching our focus from Riot to Kentucky helped a lot as well. And we were able to just have more of a single-minded approach and have to worry about cross-compiling or what boards we were going to use, so we could make more progress that way. One thing that we do wish we would have had time to get to was sending actual sensor data throughout our network instead of just the generic messaging that we were using while testing our network. And then we also did not get to any of our stretch goals.
So, in our last slide here, we're going to talk about what would we do would we be continuing this project. So the next steps that we'd work on would be getting the sensor alerts working, as Justin just said. After that, we'd try to port our software over to actual hardware, so that way we could see what or kind of the discrepancies between Kuja, the simulation environment, and the real world numbers. That way we could get more of a accurate view of everything happening. And then finally, get a web server set up so each board router can send the information it has to a central location. So that way you could have multiple board routers set up and just view could view all the information in one location. So thank you guys for listening, and do you have any questions?
One little one, just because I didn't understand. Do you have the chart where it showed the power consumption?
Sure. Nope.
Do you want the
bar graph?
Okay. Yep, that one.
No.
Table.
Yeah.
One thing before you ask, this is a typo and it should be the same across all of them.
That was my question, is why is there an order of magnitude difference?
That was probably my fault.
Yeah.
But I had one more here. On the bottom line, the transmit power.
Yep.
I would have thought that would have been the smallest for the square two board.
Is it the same with that bottom right cell, where again it's an order of magnitude difference? Is that a typo?
Oh, the 0.29 as opposed to 0.02. Yeah,
Yes.
I believe that's a typo.
Okay.
Maybe, yes.
But for Dean's question, I'm not exactly sure.
Yeah, I'm thinking transmit power should be better if you don't go so far.
Yes.
And it seemed like in the square 2 border router transmission should have been smaller.
It probably should have
It's the
been.
largest
Yeah.
one. Oh.
Yeah. That probably indicates that we need to do more testing and to average it out and doing that, so we don't have any discrepancies like that.
Yeah, but also dealing with simulators and values this small, there could definitely be like some discrepancy in it. It'd be best if we were able to run the tests a lot more than we were able to.
Yeah. One
Good
thing
question.
that could affect it too is sometimes when using 2 border routers, there could be some overlap. So we weren't able to completely eliminate that. So maybe it was, there's overlap, so it's kind of doing the same thing twice instead of just doing it once. There's that extra messaging coming in for both border routers.
And what you mean, or like just to kind of clarify that, when we have 2 border routers, each one kind of gets their own network, like subset of the network, and there can sometimes be nodes that end up on both networks. So that might be the reason. Can't verify it, or at least right now. But yeah, good question.
Anything else? All right. Well, thank you.
Thanks again.
Well, I'd like to thank all of you for coming to hear my presentation today. My name is Jesse, and I'm going to tell you about my capstone project in computer science. The project that I completed is a music composition version control software, and that's what we will be discussing today. So as I mentioned, this project is part of the requirements for completing the undergraduate course in software projects capstone. And as part of those projects, I had the privilege and opportunity to choose a project that I wanted to work on. So I met with my instructors, Alex and Dean, and we talked about what kind of options I would have. And I wanted to do something to do with music because that's my minor field of study, in addition to my major of computer science. So I was really hoping to do something to do with music, and they said that I would need to work with the music department in order to do that. So I consulted with a few people in the department and had the privilege of meeting Dr. Kyle Vanderberg, who agreed to sponsor me in the project. That's why I appear to be a team of one here, but I've had a lot of support from the departments. So next I'm going to talk about the objective of this software project. The objective of this project is to help composers of music track and view changes they make to their compositions in standard music notation. This project addresses a real problem and a real opportunity in the music world because composers of music need a way to organize their work process, and they need to have a central location to keep everything together. This project is also a really great exercise in software development, and I'll be outlining a lot of those details in the following slides here. So to start with, I've included just a little snippet of some music in standard notation. And this is kind of what the objective of the project is to give the music composer a software interface for viewing their music in this notation, as opposed to any other type of notation like text. It really has to be in this notation because that's kind of like a language for musicians, that any musician can see music in this notation and have at least some idea of what's going on in the music.
For those of you less familiar with music, this is just a simple 3-state example with the treble clef and bass clef with some notes of varying duration and tone, as well as some lyrics. This example was submitted by Dr. Vandenberg himself. So the big question was, how are we going to implement this project? And what we decided to do was work with the Music XML format. Music XML extends a file format called XML, or Extensible Markup Language, which is kind of a multi-purpose programming language that describes how to store and display data. In this case, that data is music. So that's why we chose the Music XML. It's a standard and open file format for exchanging digital sheet music. And one of the reasons that it works so well for exchanging digital sheet music is that it's compatible with hundreds of different applications. So there's a great diversity of software out there already that uses this format. And that's why we wanted to plug into this, this notation here for Music XML to sort of take advantage of that great compatibility. As for the software side, the project is located on a website on the internet, and we're located just a cloud service hosting company in order to host the software project on the internet. I've also included an example here of some Music XML notation, and you might notice how much this contrasts with the common music notation example that I showed you earlier. As opposed to staves and lines and notes, instead we see a dizzying spiral of XML tags and variable names and attribute values. So I think that this illustration really shows the challenge in bridging that gap between Music XML format and common music notation. So that's kind of the challenge here. We're trying to convert this into that nice, easy to read music common notation. And I'd like to tell you a few more details about the software platform that I implemented for this project. I chose a website on the internet because websites are already very cross-compatible. They're easy to pull up at a moment's notice from Mac computers, PCs, in a variety of different web browsers, Firefox, Chrome, Internet Explorer. It's pretty easy to access those from any location. There's also a very large code library for internet website development, and that makes it really easy to deploy. There's also an extra layer of security here too, because as opposed to an installable, executable program that the customer would have to install on their computer before they could even work with it at all, which would also open up some security vulnerabilities. This way, it's just a website that they can pull up right away, and they don't have to worry about installing anything or updating anything. It's just ready to go right away. And the programming languages that I'm working with here are just HTML, JavaScript, and PHP. Other options might have included Microsoft.NET or the Java platform. But considering that I already had some experience with these, and I've already developed some projects for corporate clients with these languages, I decided to work with those as a way to implement this project. And my sponsor fortunately agreed that that was a good way to develop the project. So the objective of this project, as I mentioned, is version control software. It helps composers of music manage different versions of their compositions. So we identified 3 different functions that will help composers do that. The first function is a file repository. That's a pretty basic element of every version control system. You need a place to store those files so that you can store each of those different versions. And the way that I implemented that was with a plugin called DropZone. I'll tell you a little bit more about that on the next slide. Another element that we're implementing to help composers manage their versions is with an engine to display that music in common music notation, and that's with an engine called Open Sheet Music Display. I'll show you an example of that here as well too. And finally, we also want the ability to compare differences between versions so that the composer can easily see what exactly has changed between those different versions. That turned out to be a good exercise in data parsing, and I'll tell you more about that in one of the next slides too. So coming back to the uploading file process, that's with a free open source, freely licensed software called DropZone. I looked around for a few different uploading modules before settling on DropZone, but it was probably the easiest part of the project to implement. All I had to do was copy the source code from the website, which is freely licensed, and then configure a simple PHP script on the server side. And then it was pretty much ready to go. The only extra step after that was enabling write permissions in the folder that we're using to store that XML data. The next step was developing the music notation in the web browser. And as I mentioned, that's being accomplished with an engine called Open Sheet Music Display. Open Sheet Music Display renders the music XML with another software engine called VexFlow. And what that does is it just draws the musical elements, notes, measures, and so forth in the HTML5 canvas on the website, which is a relatively new innovation in web development, but it's proven very, very flexible and dynamic. Another reason that I chose Open Sheet Music Display was because it's very well documented. There was another one that I considered called ABC Web, but that one didn't have quite as good of documentation, and it also had some extra bells and whistles that seemed to distract from the music notation a little bit. So that's why we stuck with Open Sheet Music Display. And then, about halfway through the semester, we arrived at this problem of comparing differences between versions. And that was kind of like hitting a brick wall, because it turned out that there wasn't really any good engine out there already for comparing XML. I kind of thought that we would be able to tap into the parsing engine that works with web browsers, thinking that web browsers already parse XML in the HTML format. I thought it might be really easy to tap into that, but it turns out that those parsing functions aren't necessarily available at the web scripting development level. So that turned out to be a real challenge. And I spent much of the remainder of the semester working on that problem. So in order to begin working on that, first, I decided we need a list of what files have been uploaded to the website. But rather than just hard code a list as those files are added, I programmed a a tiny little script in PHP that iterates through the uploads folder and creates that list in a menu on the fly, so that no matter when or how many files are added, the website can just display those options in a drop-down menu right away. The next step in comparing differences between versions is to load the XML file in the client-side JavaScript program. One of the earlier versions we had worked with was a comparison engine on the server side, but as it turned out, especially with these cloud hosting platforms, system resources are very limited. So they wouldn't actually allow the program all of the memory that it needed to do that comparison. So by switching to a client-side JavaScript program, it really opened a lot of doors into more complexity of analysis. And for those of you more familiar with programming, the object that does that in JavaScript is called the XML HTTP request object. What that does is it calls an asynchronous request to the server in order to pull back that XML data as a sequence or a string that's just serialized in a linear format. And that also solved another problem with the hierarchical nature of XML. As you might have noticed in that example with the music XML data there, there's a lot of different levels, and each level can have any number of elements, but it can actually be simplified into a simple linear sequence, and that made the parsing a lot easier. So how do we do that? How do we parse this complex XML data and turn it into something useful that we can manipulate? Well, the next step in that process is to separate the musical data from the formatting data. The music XML format includes data for describing the musical objects, and it has a lot of data for the formatting as a document on the screen. So the first step was just identifying which of those elements are interesting and meaningful. The ones that we identified for that purpose are outlined here. Part ID, measure number, step, octave, type, and text, which correlate approximately to instrument or voice. Measure number, that's exactly what it sounds like. Step is the tone or the frequency of the sound that the musician will be playing. Octave is part of that as well. Type is the duration of the musical note. And then text is a lyrical word, or what a voice would be singing. So I've included a little bit of the algorithmic description here. Depending on how much time we have, I could go into this in a lot more detail. The essential idea is to, in order to find those differences between versions, we also have to consider a number of different possibilities, because a simple linear comparison side by side would identify small differences between versions, but not necessarily larger changes like an insertion or a deletion of a measure before the change had happened. So what we arrived at is basically a measure by measure enumeration of each of the elements of interest that I mentioned in the previous slide. What that basically does is it compares every measure in one document with every measure in the second document. It identifies if every meaningful attribute, excluding formatting data, in the one measure in the one document is equal or not to every meaningful attribute in the first measure in the second document, and so on and so forth. And there's a whole lot more details that I'd be happy to talk about if anyone has more questions about that. But after it identifies what has changed between versions, then it just displays on the screen which measure numbers are different from the other version. So next I'd be happy to show you a demonstration of the website project. I'll just see if I can minimize this. So we'll start with the comparison here. Dr. Vandenberg provided 4 different versions of music that we can compare with here. The first 2 versions we got just had one difference between them, and the algorithm identifies that as a difference in part P1, measure 3. So if we click over to the display here, well, we can just click here. I can show you how that correlates with the display. So this is the first version. Let's look at part 1, measure 3, and you see that's a dotted half note C compared with the second version he sent. And keep your eyes on it because that's what's going to change here. And sure enough, that's the note that moved. And it's the only one out of this whole piece that changed between those 2 versions. So the algorithm is successful in that part. It just displays which measure number has changed so that you can click over to the display and then see for yourself. There's also 2 more versions here. And these were a little more complicated. From March, looks like. So let's see what happens here. In the second 2 versions, we found differences in 10 different measures, but they're all in part P2. Measures 13, 14, and so forth down here. And if you click over to these versions, well, they're not numbered, unfortunately, but those would correlate to the differences that have changed between those 2 versions. I can also show you the uploading page here. All this is tied together really with just a menu using the Bootstrap framework. It's a pretty simple navigation menu. Got a little information about the project and access to some of the documentation. So that's a little bit about how it works. And I think that's pretty much everything that we've accomplished so far. I think I'm really happy with the way that it's been going, and we've got that comparison pretty much nailed down so that it can identify differences between those versions, and then we can display that music and common music notation right here on the same website. So in conclusion, I'd just like to really thank the NDSU Computer Science Department for giving me the opportunity to work on this project. And I especially want to thank Dr. Kyle Vandenberg for being so generous with his time and sponsoring me with his time and guiding me through this software project. It's been a real privilege. Does anyone have any questions about the software project?
If you insert a measure, do you find that and claim it's only one measure that's different, or have you solved that problem?
Sort of have solved it, but kind of not. It turns out that in order to compare these differences, there's ultimately two different large arrays. There's one array for the first document and one array for the second document. Each of these arrays has a sequence of all of the measures and all of the parts in the music. So it's got just one big list of every part measure in the sequence. And then it iterates through each one of these arrays to identify which measures in the two different arrays have the same part identifier and the same measure number identifier. So from that, that's kind of the linear side-by-side comparison that I've shown you. In order to take that one step further and address the potential insertion or deletion of measures at some point in the music, then the program is going to compare the musical elements that were outlined in the previous slide here, each one of the notes and its duration, and identify the longest common sequence there. That's actually a recursive function. So first it identifies the longest common sequence between the two versions. Then it finds the differences and calls the function again on the second longest common sequences, and so on and so forth, which recursively identifies every difference between the two versions.
At one time you showed side by side. Is that still there?
Yeah. What I found was that it's actually easier just to copy the window pretty much. So you can open a new tab, open a new window, like so. So we'll display March 1st B with March 1st C, like so. And that's showing up pretty big on the screen here, so I'm going to resize that a little bit and just reload here. Oh, and I'm going to resize the window. Oh, is that going to work? There it is. And this way you can specify exactly, what dimensions. Oh, let's change both of them. And then you can just pick whichever version you want, like so. There might still be some room for juxtaposing those a little bit more in parallel.
So where it's at right now, though, when you find the first difference, does everything show up as a difference from there on? Or if there was an inserted?
If there was an insertion, in this algorithm, not quite yet. This one is pretty much just a linear algorithm. Fortunately, in all the versions that we've gotten so far, there aren't any of those insertions or deletions to handle yet. Well, if there aren't any more questions, just like to thank you again.
Thank you.